Welcome back to part 2 of chapter 3. So let's jump in and talk a little bit about multiple alternatives if statements. And in this, they're showing you two different ways of doing the if statements. And while they do say that it's equivalent in this example, please note that doing it these two different ways can quickly become unequivalent. So just be careful with your if statements and how you nest if statements. And what I would say is, again, if we talk about coding standard when it comes to working at a company, uh, most companies are not going to be really fond of this method. They're going to be much better off with this method. So while they both work, this method on the right is a lot better and much more readable than on the left. Especially our left example doesn't have curly brackets. Now, you may be going, but Professor Waits, you said that there was more than one line of code. You can't use brackets, and clearly this else statement has multiple lines. Technically, it doesn't. Technically, it only has one because the if else in this is seen as one block of code, as in one line. But yes, you're right. It still is really confusing and is difficult when it comes to reading this. So, for several reasons, I wouldn't use this left side. And if I was going to do something on that left side, I would include my brackets, so forth and so on. All right, so what's going on here? What we are saying is in our code, if this is true, do this. Else, then we're going to the next line of code. If this is true, do this. Else, go to this next line of code, and so forth and so on, right? But as we've said, it's really difficult. Finally, at the bottom, by the way, here, this last time this turns out to be false, and we go into this if this else, we can see that we finalize it by saying either D or F. The else statement here does not have another if. And that's kind of what terminates it. On this side, we're doing it in a much cleaner fashion. We're saying, hey, if the statement here is true, great, do this. Otherwise, check to see if this is true. No? Is this true? And so forth and so on until it gets to a line that says, okay, this is, let's just say that that's true, then it's going to do that line of code. Else, as in, this is kind of the catch-all. If none of these aren't true, then it's going to go to the catch-all, which is the else statement. Interestingly enough, you can leave this off, so you can do a bunch of if, else if, else if, else if, and have no catch-all else statement. You can or you can't. Either way. This is kind of what we just went through, and you can see this multi-way if-else statement. So again, if this is true, then do this code. Else, fall into the next if-else statement. So if true, do that. Else, and keeps falling forward through the code. Now this is a printout. I've printed the slide deck out into a PDF so I can notate it here. And so it takes the animations and essentially breaks them out to each slide on its own. And so we can say, let's suppose that the score is 70%. In this example, this first line is false, so it's not going to do that. But then it's going to check to say, hey, is this true? Well, it's not. So I forget that I have to go through each slide as well. So now it's going to check this line and say, because we've already said that that's not true. Is this true? Well, no, it's still false. So it's not going to do that line of code. So then it's going to get to this next one. And because we're saying greater than or equal to 70, then this would be true. Now, just so you know, if this said else if score is just greater than 70, this would be false. Because greater than is exclusionary, as in it excludes the number we're comparing against. Just kind of keep that in mind. I like to try to show real examples at the time of when there's a good example of it. So in this case, it is true. So we're going to do this line of code. And the grade is a C, so we're going to output the C. Now, just so you know, when we hit an else if that is true and works, it will then ignore all the other else ifs and else. This is really important because, as you can see, we started with the numbers and we went downwards. And we want to do that from greater to less than in this example. If we did it backwards, if we said if 60, let me try this again here. If we said if score is greater than or equal to 60, do this, else if score is greater than or equal to 70, do this. Well, the problem with this code is we would step in and our score is greater than or equal to 60, so we would do this line of code and not this line of code. Because remember what I said is once it gets a true from one of these statements, it ignores the rest of them. So we would have gotten the D and not the C because we went 60, 70, 80, so forth and so on. So make sure you start from the greater number and go down. Now there are some times where you want to do from lower to greater, but again, your score would be there would be a reason for that, and more than likely you would use the less than or equal to as your example. So in this statement, it's saying the else clause matches the most recent if clause in the same block. What they're talking about here is be careful of your indentation. So this version is actually saying if I is greater than j, do A. Else, do B. Well, this version over here is saying if then do the next if statement. So if I is greater than j, then compare if I is greater than j, then move on to this next if statement. If it's not, then just exit the code. In fact, this first line is what we've called before that one-way if. And in this, we're saying if I is greater than j, then go ahead to the next if statement, which is if I is greater than k, then do A, else do B. As you can see, these two statements, while they look similar, because of our indentation and our if our one-lined if statements, we have two different things going on. Again, this is a great example of why a lot of organizations say one-lined ifs still need to have the curly brackets. This is saying nothing is printed from the preceding statement. To force the else statement to match the first if clause, you must add a pair of braces. So what they're trying to conclude here is if you want to get this to look more like this, then you can use brackets. That's what I'm saying to you anyways, is just use brackets, because these two can turn out to be, this statement right here can easily become this statement because of tabbing, and so it's just best to use the curly brackets at all times. So what are some common errors that we come across when we are working with if statements? This is a pretty common one. We definitely see this where we put a semicolon at the end of the if statement. Semicolons are terminators. So what's happening here is it's actually going to check this, and no matter whether it's true or false, it's just not going to do anything. And because of that, our compiler, when there's brackets like this with nothing above it to really say what to do with that bracket, it just sees this as a block of code and will literally just come in here and do the code. So in this case, this wouldn't translate to really anything, and our compiler would automatically come into this code every single time. This is definitely harder to find in our mistakes because the semicolon is such a small character, and we're so used to seeing semicolons at the end of code, it just happens. Another common error, and I don't think they talk about it, is again using if statements with single equal sign. So if we want to say if radius is equal to 0, then sorry, as I have temporary malfunctions. Yeah, there we go. Get the pin correct. You're going to get an error here because the compiler is smart enough to know that you're not really trying to take 0 and assign it to radius. But in some cases, it may not give you an error. And what would happen is you would actually assign 0 to radius. You wouldn't be comparing 0 to the radius. Remember, if we want to compare, we have to use, sometimes the pen just doesn't want to cooperate. We have to use 2 equal signs. All right, let's take a look at this tip. What they're showing in this tip is how you can do the one-lined ifs and make more sense. Because what's happening here is, in this side, we're first doing the comparison. We're saying, is number modulus of 2 equal to 0? Or equivalent to 0? But before we go any further, let's take just a moment to talk about modulus. This is what's known as the modulus sign. And modulus says, tell me what the remainder is. So 5 modulus 2 equals so the remainder here is 1. So we're going to put the remainder 1 here. This is our answer to the modulus. The remainder is always our answer. Modulus is a great way to check to see if a number is even or odd, because we can say anything modulus 2 will let us know x modulus 2. If the remainder is 0, then it's even. If the remainder is 1, then it's odd. One last thing about modulus. Modulus is a great way to get a number in between something. So let's say I want a number between 1 and 10. Now remember, when we use modulus, one of the answers to modulus can be 0. So if we want something that is 1 through 10, we're going to have to add 1 to get our answer. So x modulus 10, no matter what number is in x, we're going to get a number now from 0 to 9. So if we ever need to know, hey, give me a number between 1 and 10, and someone gives us 212, modulus 10 is, on this, would be remainder of 2. If they gave us 200, then the remainder is 0. And that's why we take this. So let me clean this up again a little bit. So we're trying to get a number between 1 and 10. So we say x modulus 10 and then we always say number equals number plus 1, because the answer to this is 0 through 9 and we want 1 to 10. So we always say number plus 1. Just a little side note about modulus and some places that it's worthwhile to use modulus, especially if you are looking to do a random number and you need a random number, let's say between 0 and 99. Then the easiest way to do that is whatever the random number generator creates. We can, we would have to multiply it first by 100 to get rid of the decimal. And then we would say, this is random, sorry. We would, and let's say we just assign it to x. Then we would say x modulus 100. And now y contains a number 0 through 99. So with that being said, back to our example. This is saying whatever the number remainder of 2 is, and this, when you see that, they're asking is number even or odd, so that's why they're even saying even or odd, and take that response. So we're doing math here first, and then comparing it to 0, and then assigning that result back into whether it's even or not. So this is a shortcut to all this code. And the reason why that works is our comparison here will return a true or a false, a true or a false. So that's why we can go ahead and assign it all in one line. In this, please know that if we already have a variable that stands for a Boolean, like this even stands for a Boolean, if we already have a variable that is true or false, we don't actually have to be explicit and compare it to true or false. See, this is being explicit. We're comparing even, whether it's true or false. Because even is already a Boolean, we can just eliminate this part and just check, because the if statement's always looking for whether something is true or false. So if the variable itself is already true or false, you can just compare it. In our next video, we're going to jump in and talk a little bit about logical operators. We'll see you then.